Hello class, this is solving radical equations. This is a part of the radicals unit 1.1, and this is going to be section D, so 1.1D. So far we've practiced simplifying radicals, adding, subtracting them, and doing multiplication along with double distributive property. And we're going to be applying those skills through solving radical equations. So anytime you're solving an equation, it requires isolation of the variable. Isolation means you're getting it alone. There. So equations that contain a variable inside of the radical require algebraic manipulation of the equation so that the variable comes out from underneath the radical. This can be accomplished by raising both sides of the equation to the nth power, where n is your index or root of the radical. So if you have a square root symbol, that means the index is a 2. So in order to get rid of that, you would raise it to the second power. You would square both sides. If it happened to be a cubed root problem, to get rid of that, you would raise it to the third power on both sides. And that would essentially just eliminate both the radical and the exponent, and you'd be left with whatever's inside. So when the index is an even number, if it's 2 or 4 or higher, but still even, you can introduce what we call extraneous solutions. And these are solutions that don't actually work. So it is necessary to verify that any answers obtained actually do work. And you can verify answers. This can be accomplished by plugging in the solution, right? The answer that you got, what is thought to be the solution, back into the original equation to see if the resulting values satisfy the equation, right? Do they make the equation true? It's also good practice to check solutions when there's an odd index to identify, is it still making it true? And if not, there's going to be an algebra mistake somewhere in there. But there should not be any extraneous solutions for when the index is odd. So if it's cubed root or fifth root or higher. So let's take a look at our 4 general steps for solving radical equations. First, you want to isolate the radical and identify the index. That means you're getting your radical completely alone on one side, so everything is going to be moved to the other side. And then you ask yourself, okay, what is the index? What is the n? Is it the square root, cube root, etc.? Once you have that radical isolated, you're going to raise both sides of the equation to the nth power. So if it's square root, you're going to square both sides of your equation. If it's cube root, you'll do the cube power or third power. You're going to repeat these steps over and over until all radicals of the variables are eliminated. So there are some longer problems that we'll see where isolating one of the radicals, you might have radicals on the other side of the equation, and after squaring, they might still exist in the problem. So then you're going to have to isolate the radical on the other side and just kind of continue that process. But we'll see examples where you'll have to repeat that step. Once all radicals are gone, you can use algebraic techniques like factoring, combining like terms, etc., to isolate the variable. So if it's a two-step equation or multi-step equation, if it's linear, or if it's quadratic, you can factor. You could use quadratic formula. You're just going to use any other algebraic techniques that you already know to isolate the variable. And then last but not least, your fourth step is to check your answer. If you have any extraneous solutions, you want to make sure you eliminate those and do not include those. So let's take a look at our first example. We have the square root of 5 minus x subtracted by 3. Notice the radical ends right here. So this minus 3 is separate from the square root. So in step 1, when we want to isolate the radical, we're going to add 3 to both sides of the equation. And that way our radical is isolated and all alone. Then we're going to go ahead and to step 2, we're going to square both sides. So we're raising it to the second power. When that happens, your radical is eliminated and that power goes away. And you're left with what's inside. In this case, it's 5 minus x. And then your third step is to solve for x. This is just a linear equation. We have all of our variables on one side, but we have constants on both sides. So we're going to subtract 5 from each side. 5 minus 5 is gone. You're left with negative x. 9 minus 5 gives you 4. And then this last step here, the coefficient of x is negative. We don't want that, so we're going to divide both sides by negative 1. And that gives us a positive x equals negative 4. Then we're going to take that negative 4 and we're going to plug it back into the original equation where that x is. So here it is. There's that negative 4 in for the x. 5 minus a negative 4 becomes positive 9. We can simplify the square root of 9 to be 3. Subtract 3 minus 3, we get 0. The other side was 0 the whole time. And 0 equals 0. This is true. So that's what that little check mark means. So since negative 4 makes the equation true, we know it is a valid solution. All right, so here's our next example, example B. In this problem, we have two radicals that are being subtracted. Now the insides are different, so these are not like radicals. We cannot combine them. They have to stay separate. We have the square root of x squared minus 2 and the square root of x plus 4. So the first step, isolate the radicals. So what I'm going to do is I'm going to add the square root of x plus 4 to both sides of my equation. And when I do that, the square root is eliminated from the left side. 0 plus the square root of x plus 4 is just going to leave it just as that, the square root of x plus 4. So now I have isolated one of the radicals. And we're kind of lucky in this example because on the other side of the equation, it's another radical that is alone. There's no extra terms like a minus 3 or plus 4 along with that radical. So what's nice about that is when we go ahead and square both sides, the radicals are eliminated for each of these. So all we're left with is what was inside of each radical on each side of your equation. Now here we have a quadratic equation. And so when solving a quadratic equation, we want to get it set equal to 0 in factor so we can apply the zero products property. So you're going to subtract x from each side, and that gives us x squared minus x minus 2 is equal to 4. And then we also want to subtract 4 from each side, and that is how we get x squared minus x minus 6. So this quadratic needs to be factored. You may have seen in previous classes doing something like an x, taking the a value, which is 1, and multiplying it with c to see, okay, that's negative 6. And then looking at your b value, in this case is negative 1, and then trying to figure out, okay, what are different factors of 6, like 1 and 6, 2 and 3, that multiply to make negative 6, but also add to make negative 1. So that means the bigger number would have to be negative if they add to make a negative 1, and 1 minus 6 is not, but 2 minus 3 is. So right there is how we can factor this quadratic. It's going to be x plus 2 and x minus 3. Here's my plus 2 and here's my minus 3. Now remember, this is really only going to work with that first step when the a value in front is 1. If this a value in front was not 1, it would not work with those two numbers right here. You'd have to then factor using the box method or by grouping with parentheses. And that's something that we can review on a separate day or in a separate class. These will not always end up being quadratics. This very well could have just been an x minus 2 underneath the radical, and then this would not have required any factoring or solving a quadratic equation. Another way to solve this quadratic I mentioned earlier was your quadratic formula, negative b plus or minus the square root of b squared minus 4ac all over 2 times a, where the a is 1, the b is negative 1, and the c is this negative 6. So you plug those three numbers into this and simplify. And when simplifying that, this plus or minus is going to give you two solutions, one of them being negative 2 and one of them being 3. So now that we have, and now I did not finish this example where this is factored. Zero product property says if something times another something equals 0, one of those somethings must be 0. So that's how we get the negative 2 and the positive 3. Whereas if it's x plus 2, if that were to equal 0, I subtract 2 from each side, that means x must be negative 2. Same thing for the x minus 3. If x minus 3 had to be 0, well then that means the x has to be a positive 3. You get that by moving that 3 to the other side. So now we have our two solutions, -2, -3, and we want to check them. So first, I'm going to plug -2 in for both x values into the original equation up here at the top of my page. And then I'm also going to do it for 3. I plug 3 in for both x values. And then you just go ahead and simplify using your order of operations. And as long as it gives you an equation that's true, you are confirming that those are solutions to your equation. So since these are both true, down here, that's what that little check mark is. I can confirm that yes, my solutions are x equals -2 and x equals 3. That's my final answer. Those are the solutions. So I'm going to stop there for the notes. In the next video, I will go over a couple different examples. I'm just going to flip over, just kind of give you a brief, a sneak peek. In this example, we have two radicals, but there's an additional constant in the problem. So when I go ahead and try doing my squaring, I'm not going to just eliminate this radical right away, and it's going to require some extra steps. So we'll worry about this at a later date. We'll just practice the first two examples that I showed you. Here's another example we'll work on in the future, and that's when it's not square root, it's cube root. And then last but not least, what happens when you have the square root ended up equal to a negative. And we'll talk about that a little bit later. Sneak peek, there's no solution. But we'll discuss these examples in another video. For today, now that this video is done, I would like you to try the couple problems that are posted where there are two radicals where there's not going to be an extra constant, or there's just one radical with a constant. And you can kind of apply the methods that I showed you in these two examples. Good luck.